return statement and the following expressions in the C++ programming language. A return statement is used in order to end the execution of a function. Whenever you have a function and you want to terminate the execution of this function or end the execution of this function, you need to use the return statement. And even you can place the return statement in any way inside your function, in any line in your function. So those statements which are following or which are follows by the return statement are not be executed. They are not going to be executed. So your function ends or stops executing when it says the return statement. So, and even this return statement can be used in order uh, to prevent abnormal termination of your program. You can terminate your application or your program sometimes whenever some abnormal execution is taking place. But in a void type of function, we know that we've got so many different types of functions: void, int, string, and char, and the others. In the void type, we don't have a return statement, okay? But instead of the statement, the function ends by the last bracket in your function. You know that whenever you are creating a function, you need to have an open bracket and a closing bracket. So your function in the void type is going to be stop executing when it says this closing bracket. Here in this function, we are calling this function into this variable. So the result of this function is going to be placed inside variable, which we know what is the POW function, which is a library function. This one to power this one, and the result is going to be placed in this variable. And in this function, we've got integer. We need to have a return statement. So, for example, you say int sum. It takes two parameters, and we are defining this variable, and we say the variable equals to this parameter plus this parameter, and at the end we are returning the result. Only the result is going to be returned after executing this function. Here we've got the return type, and this value is going to be returned. And even you can return the expression, okay, which you can say return num1 plus num2. So the addition of those two numbers is going to be returned after the execution of this function. And in this function, we are dividing a number to another number. This is the function prototype. It takes two parameters, this one divided by this one, and we are defining those two variables. And if say enter two numbers, and I will divide the first one by second one, we are entering those two numbers, and we are calling this function to be applied on those two variables which we already defined and entered. So let's see what is inside the function. This is the function. It takes two arguments or two variables. So, but if the second one is 0, that means an exception. We can't divide any number by 0. So if it is 0, we say return or print this expression, and we are returning the function. We are ending the function here, okay? Because an abnormal execution just happened, an exception just happened. Else, if this one is not true, we are performing the division. The first one is going to be divided by the second one. But if we enter 0, we are terminating the function here, okay? So we can use, we've already used the return statement before the last bracket, but now we've used in the middle of our function. So you can place the return anywhere you want to perform the desired functionality of your function. And here we have another example. We've got two integer, and we've initialized, and we are calculating the summation of them, and we are placing the calculation or the summation into this variable. So what happens, we say this variable equals to the calling of this function. So it goes to call that function. We've already defined the function prototype, and it goes to this function. It takes those two parameters, and we are returning the result of the addition. So after it comes back from the function, the result is going to be assigned to this variable, and we are printing the total or the last result of the function. So this is the structure chart. So through the main program, the value 1 and the value 2 is going to be passed to the some function, and then the result or the total is going to be brought back to the main function. Here we can say the value 1 which is in the main program is going to be replaced with the num1 and the value to the num2, which are the parameters or the arguments of the function, and it returns the summation of those two parameters to where, to the total. Why? Because we've said the total equals to the calling of this function or whatever is going to happen inside this function. A returning a boolean value is a type of function which is going to be called the boolean, so the function can return true or false, only two different values, and the return time is going to be defined or declared using bool instead of saying int or void or char or whatever. We are saying bool for those functions which we want to return true or false. And we need to use the return statement at the end of all function to return true or false. And so let's see this example. We are saying bool is even, it takes an integer value. Okay, so this is the function prototype. Here we are having the main program or the main function. We say we are defining this value and we are entering it, and let's see, we are checking if this number is even or not. If is even val, so this val is going to be taken to that function because we've called that function here, so it directly goes to that function is even. So we have got a variable which type is bool and the name is status. If number modulus 2 equals to 1, that means the number is odd. If this one is true, that means the number is odd. If it is 0, so it's going to be true, the status is going to be true, which is the result is going to be 0, so the result, the status is going to be true, and then we are returning the status. So the status here is going to be true, so this condition is going to be true, and this one is going to be executed, which is printing val1 is even. This is how you use a boolean value inside your function, or boolean type of boolean return type of the function, or boolean.
The local and global variables. So those variables which are defined inside the function are called local variables, which are local to that function. They can be used inside only that function. So if they are used inside the other functions or in the main function, they need to be declared again. So they are hidden from the statements in other functions. So you can't use this variable in the other functions, and the other functions can't access this variable. Okay, so those variables which are defined inside a specific function are hidden to the other functions, but the other functions may have their own separate or their own local or distinct variables with the same name. So when you say a variable name inside this function, you can say the variable name inside the other function, but they are going to be separate variables. They are not going to affect each other. They are only distinct to their own functions. And let's see, we've got the main functions int num equals to 1, and in another functions int num equals to 20. So in the main function, this one, the num is holding this value, while in the another function the num is going to be 20. So they are going to be totally different. So this variable is going to be visible inside only this function, while this one is going to be visible inside only this function. So they are totally different. So but we've got, other types of the variable which is called global variable, but let's talk a bit more about the local variables. So the local variables exist only while the function is executing. For example, when you are calling that function and that function is having a local variable, so that local variable is only available when that function is in execution. Okay, so when the function starts executing, the variables and its parameters or the statements are going to be created in memory, and then when the function stops executing, those variable and statements are going to be destroyed. But the global variables are those variables which are defined outside all the function in the program. We are not going to define them inside the main function or the other functions which we are going to be defined by ourselves. So and this variable can be used, this global variable can be used inside entire your program, anywhere inside your program, in every single function. The global variables can be used, while the local variables can be used inside only their own functions. So the global variables are accessible by all the functions inside your entire program, while the local variables are only accessible or executed or available inside that function with which this variable has been defined. And there is a suggestion which says you should avoid using global variables because they make programs difficult to debug. So you may mess your program, you can't control it very much. So and any global variable that you create, you should use global constant. So such as here global constant, for example, those variables are used by your entire function and their values are not going to be changed, and they can be used in every single function inside your program. Like here, they can be used in every single statement inside any function of your program. So how to initialize the local and global variables? The local variables are not automatically initialized. You need to initialize them by yourself. You need to give them a value. While the global variables are going to be initialized to 0 or null character, or the 0 in numeric when the variable is defined. So you're not having that control. You need to define or initialize the local variables whenever you are creating them. But for the global variables, if you don't give them any value, the program automatically, the C++ automatically gives them 0 to numeric variables and null to character variables. And we've got another type which is called static local variables. So you know that the local variables are only existing when the function is executing, and we know that when that function stops executing or the program goes out from that function, the content of the local variables are going to be lost. Okay, so they are going to be lost, they are going to be destroyed inside the memory. But the static local variables retain their contents between the function calls. Whenever you are going outside that function, the last value of the static local variable is going to be held inside the variable. So this is very important, or the main difference between the local variable and static local variables. And the static local variables are defined and initialized only the first time the function is executed. So the 0 is going to be the default initialization value if you don't give them any value. So only one time you are going to give them a value. So this is a very good example to understand the local variables. Let's say we've got this program and we are going to have this function which is void show local, and this is the function prototype, and inside the main function we are calling that function 2 times. Okay, let's see what's inside that function. We've got int local num. This is a local variable, it's not a static local variable, it's only a plain local variable, and we have given it a 5 to it, so the 5 is going to be the value inside that function, and we are printing down that variable. Okay, and then we can say local num is 99, so it's going to be updated to 99. So what is going to be happening here? 5 is going to be printed in the first call. So after the first call, we are going to change the value of the local num to 99, but when we go outside this function, this is going to be reset. The value of local num is going to be lost. So in the first function call, 5 is going to be printed. Then we are calling that function again. So it goes back to that function and it starts initializing the local num again to 5. And 5 again is going to be printed. So we are going to update to 99. But whenever we are going outside this function, any value which is inside the local variable is going to be lost. But here in this program you are going to use static variables. Okay, static local variables. Look at here, and we are defining this function, which is the function prototype. In the main function, we've got this loop which iterates 5 times, and we are calling this function 5 times. So let's see what happens in the first call. The first call, we are defining static int this variable, okay, stat num. We are printing it, okay. So the value at the first time is going to be 0. We said that the value is going to be 0 initially if you don't initialize it, and then we are going to increment it by 1, so it's going to be 1. Whenever we are going outside this function, this value retains, okay. The last value of the variable, the static local variable, is going to be remain. It's not going to be lost. So at the first time when you are calling that function, the 0 is going to be printed. So the count is going to be incremented by 1. So 1 is not 1 is less than 5. Yes, we are calling that function again. Remember, the last value of the start name when we went outside of this function was 1, so it starts from 1. So in the second time, 1 is going to be printed, then it's going to be 2. We are calling it again, 2 is going to be printed, 3 and 4. This is the main difference between the local variable and static local variable. The local variables are losing their content after going out from the function, from the defined function, but static local variables are retaining their value. So if we initialize the static local variable to 5, at the first time 5 is going to be printed, it's going to be 6. So when it goes out, this 6 is going to be held inside that variable. It's not going to be lost. So when the function is coming back again to execute, sorry, the main function, when it's coming back again to execute this function, the stat name returns the last value. This is not going to be executed anymore because we've got a static int. So 6 is going to be printed, incremented by 1, 7 and 8 and 9. So 5 times the main loop, the main function, the loop in the main function is going to be executed. So 5 times we are calling that function, and so the value is going to be incremented, and the value of the static local variable is going to be held, or they are not going to be lost. Okay, there is something called using reference variables as parameters, and we are using this mechanism to allow function to work with the original argument from the function call, not a copy of the argument. What does that mean? When you are passing a variable as a reference variable, using reference variable, the variable we have sent is going to be changed. It's going to be, it's going to be worked by the function we are calling. We are going to modify that value which we are sending through the main function to a specific function which is defined or created by the user. So let's see, and we need to define the reference variable using this ampersand symbol, such as here in the function prototype. You need to write down this ampersand symbol into those parameters or arguments of the function. So if you modify anything inside this variable, it's going to be changed. It's going to be applied to that variable which it refers to in the main function. So let's see an example. Here we are having this program, and this is the function prototype, and now we are seeing a reference. You are passing a parameter by its reference. Let's see, we've got value to 4, and we are printing the value, and then we are calling this function, and we are sending this value, but this value have been passed to the function by reference. So the 4 is going to be printed, and then we are calling that function. Let's see what's inside that function. And inside the function we are receiving that parameter, and that parameter which it was the value, okay, the value variable which we had in the main function. This one, the value, is going to be replaced with revvar, and we are multiplying the revvar by 2. So it was 4, and it's going to be 8. So when this function is going to be this function is going to be executed. The value of the ref var is going to be 8, which is the value variable. So when we are printing the value again, 8 is going to be printed because we have sent or we've passed this variable by reference. So there are some notes to be taken into account. Each reference parameter must contain this ampersand symbol. Space between type and the ampersand symbol is not important. You need to use this ampersand symbol in both prototype and the header of the main function and the header of the user defined function. So we can use only variable to pass, and we need to use when we want that value in the main function or in the calling function area can be changed by the function we are calling. And there is something else in C++ programming language which is called default argument. So default argument is an argument that is passed automatically to a parameter if the argument is missing on the function call. What does that mean? Whenever we are calling a function, we need to specify all the parameters that function needs to be passed through. So but sometimes we may not pass all the parameters which are required by the function. So what happens here, in this case the function can give a default value to that parameter. So it must be a constant declared in the prototype, like here this is going to be a default. If we don't pass any value to this function in the main program when we are calling it, the function is going to give 0 to that variable, to that parameter. So for example, here in this function we've got 3 parameters. Okay, so some of them has default but some of them doesn't have. For example, this one doesn't have any a default value, but this one has and this one has. Let's see this example. And look, void display stars. We are creating a function to display some stars. Int 10, int 1. They are default arguments, but we may change them. If we don't pass any value to that function when you are calling it, the function takes this one as 10 and this one as 1. Look here, we are calling that function display stars but no parameter. So what happens? Those values are going to be used inside the function. So the int calls and int rows in the function. So this is going to be 10 and this one is going to be 1. Why? Because in the function prototype we have used the default arguments here. This one is going to be 10 by default and this one is 1 by default if we don't pass any value. But here we are only passing one value which affects only the rows. The column is going to be the default one, which is this other one is going to be calls, which is 10, and the rows is going to be how much? 5. Okay, and here we are saying, sorry, this one is going to be applied for calls. So the first value is going to be changed with this one, this 5, and the rows is going to be default, which is 1. So this 5 is going to be replaced to this 10. So this 10 is becoming 5. It's not going to take the default value. Why? Because we have sent a parameter. So what is going to be in the output? 5 calls and only 1 row. Why? Because the row default is 1, but we have sent 5 to the calls, so the calls are going to be replaced to 5. But here we are calling that function but sending 2 parameters, so the function doesn't take the default argument. So this 7 is going to be for the columns and the 3 is going to be for the rows. So we will be having 7 calls and 3 rows. This is how a default argument works. So we may get to some point that a function prototype or function header may have some parameters. Some of them has default values and some of them doesn't have any default value. For example, this one doesn't have, but those are having default values which are 0. But in this case we need to use the defaultless values first in the declaration of the parameters. So this one is going to be placed first. Look here in this function, this one and this one are defaultless parameters, but this one has a default value. But we need to declare the defaultless parameters first, but this one is not true because we've used this one after that one. So this one must be here, so it's not okay, but this one is okay. Why? Because you've used the defaultless parameters first in the declaration of the parameters of the function. Look at here, if an argument is omitted, is missed in a function call, or arguments after it must also be omitted. For example, we may have get some function have 3 parameters, but we are only passing 2 of them, so the third one is going to be the default one. But here in this case it's okay, so all the arguments after it are going to be omitted. We can't use we can't set a space here, we just omit everything but by writing only a comma. So this one is okay, but this one is not true. It's going to give you an error when you are compiling your program. You need to omit everything when a parameter is missed in the function call. Look at this example. We've got this function which takes 4 parameters. 2 of them are having default values, but 2 of them are defaultless. So this one is legal. You can use this one, passing this one to this one, this one to this one, this one to that one, and that one to that one. And this one is also legal. This one to this one, this one to this one, this one to that one, this one to this one, this one to this one. So those 2 are going to take the default values, okay, but here only that one is taking the default value. So here we are passing parameters to only this one and this one and that one, but we can't. Why? Because we have omitted this parameter. So if this parameter is omitted, any parameter after it is going to be omitted as well. So this one is not true. And these are illegals as well. Why? Because we've got 2 defaultless parameters. So when we have defaultless parameters, they must be declared first in the function prototype or the function header. This one as well, this one must be declared first, and we can't pass a reference by value in whenever you are using default argument. And we've got overloaded functions. Overloaded functions have the same name but different parameter lists. So they are going to be defined as the same as the normal functions, but they've got different parameter lists, and we are going to see them in an example. And they can be used to create functions that perform the same task but take different parameter types. Sometimes they may take integer parameters, sometimes they may take a floating point, and sometimes they may take different number of parameters, 3 parameter, 2 parameter, 1 parameter. So this recognition is going to be done by the compiler. The compiler will determine which version of the function to call by argument and parameter list. So whenever you are sending or passing different parameters, it is the compiler that know which version of the function to be called. Look at here, these are the overloaded functions. So we are going to define them 4 times. Get dimensions only 1 parameter. So that means if we send only 1 parameter, which it is integer, this one is going to be called. This one is going to be, this version of the function is going to be executed. If we are using 2 integer parameters, this version is going to be executed. Integer and double, this one. Double and double, this one is going to be executed. Look at here, we've got 2 integer variables and 2 double variables. Whenever we are calling the function with passing only 1 integer parameter, which is length, so this version is going to be executed. And 2 integer parameters, this one is going to be executed. An integer and a double, this one is going to be executed. 2 doubles, this one is going to be executed. Look here, we've got this example. We have got 2 versions of this square function. Int square, which takes an integer parameter, double square, which takes a double parameter. We are having this variable user integer and user float inside the main function. So we are entering both of the user integer and user float. So we are calling this function, the square function, but you passing an integer parameter, which is the user int. So in this case, this version of the function is going to be executed. But in this case, when you are using a passing a float parameter, this version of the function is going to be executed. So in both cases, the functions return the multiplication of the number, the square of the number, whenever it is what is called, it is a integer or a floating point. So what happens, the program, if you enter 12 and 4.2, what happens, the first time 12 multiplied by 12 is going to be executed, and the second time 4.2 multiplied by 4.2 is going to be executed. So it is the compiler that recognizes which version of the function to be executed. In this case, it recognizes that the parameter which has been passed to the function is an integer, so the integer version of the function is going to be called, and in the second case this one is going to be called. And finally, the exit function is used to terminate the execution of a program. Whenever you are using this function, the program is going to be terminated, and you can call it in anywhere inside your program, in any function, any line inside your function. So even you can pass an integer value operating system to indicate the status of the program termination, and we are going to see it later. And this one is usually used for abnormal termination, whether it's a success of your program, you are going to terminate it, or a failure of program, or something has been done wrong in your program, so you are using this function to terminate your program. But you remember, you need to use this library in header of your file, so you can use this one to directly terminate your program. Sometimes you can pass those constants which have been defined in the header to indicate the success of the failure.